In kinematics, we need to get comfortable choosing the right equation. There's 3 or 4 equations that are available to us, and if we know a method to help us choose the right equation, that's really going to help. Let me show you the classic method that I was taught when I was in high school, and I've taught to hundreds of students. Here they are, the 3 kinematics equations. Very often we're given a problem, so they'll have some variables, a distance, an acceleration, something like that. And they won't tell us which of these 3 we need to use. The method that I like is to list out all 5 variables that are possible and then fill in the ones that we know. Let's imagine there's a rocket ship that's flying upwards. It's initially at rest and it puts its thrusters on and starts accelerating towards the sky. And we'll say when it's 100 meters high, it's got a certain velocity. Once it's traveled 100 meters, it's now going 30 meters per second upwards. And the question says, what's the acceleration of this rocket in this period of time? Okay, great. Here's a great question. So it asks for acceleration, and I initially don't know which of these 3 I need to use. So let's begin by writing down the 5 variables. The 5 are VI, VF, A, D, T. So I like to write a little list. It helps me feel organized. And a lot of students feel sort of overwhelmed when they come to new kinematics questions, especially right at the very beginning. So this is a process to help you feel like you understand what's going on. So let's write down what we know. We actually know the initial velocity. It said the rocket was at rest at the beginning. So VI is 0. The final velocity is also given to us. That's 30 meters per second. The acceleration is what we want to find. We don't know that, so let's figure it out. I'll put a question mark for that one. The distance is 100 meters, and the time we don't know and we don't care about. I'm going to write time question mark and put an X through it. Now, here's the little trick. There's always 5 variables in kinematics, these 5. There aren't different variables in this chapter. You've seen all the ones that we're going to talk about over and over and over again, VI, VF, ADT. Now, if you look at the equations, each of them has 4 variables in it. So for example, VF, VI, AT. This one has 4 of the 5 variables. Each of the equations is missing one variable. So the fastest way to figure out what the correct variable is to look at the one you don't care about. So I have 3 and I want acceleration. I don't care about the time. So I'm going to look at my equations and say which of them doesn't care about time. And that's the third one there, VF squared, VI squared plus 2AD. And if I look at my list, this list will perfectly match that one. So the trick is to always identify the variable that you don't care about. That seems to me the best way to correctly identify the equation every single time. So with that said, let's take these variables and plug them into this formula to calculate the acceleration. So I get 30 squared equals 0 squared plus 2 times A times 100. I get 900 equals 200A, so I just need to divide by 200 on both sides. So after all my calculations, I get the acceleration is 4.5 meters per second squared. Bueno. All right, so we got some variables and we managed to calculate the acceleration of the rocket going upwards as 4.5 meters per second squared. Let's do another example. The best way for you to improve your grade is with a practice exam. On my site, I have a free kinematics practice exam. Click the link below to get your practice test today. Let's imagine there's a cyclist going at 20 meters per second. They see something ahead on the road and they put the brakes on and start to slow down. Maybe there's some bush that they're going to hit. When they put the brakes on, their acceleration is negative 3.0 meters per second squared. Now we say the acceleration is negative because it's pointing in the other direction. When we're doing kinematics, we always need to choose one direction as positive and another direction is negative. Here, we'll say that the velocity to the right is positive. So acceleration is actually pointing to the left. He's going in negative acceleration. So we'll write acceleration as negative 3.0. If the cyclist does this for 5 seconds, what's the final velocity going to be? Okay, so we need to think about which is the right equation to choose. So I'm going to take these variables and put them in the list. So I have VI. I'm looking for VF. Acceleration is negative 3.0. The distance, I don't know, and I don't care about it. And the time is given to me, that's 5 seconds. So I write down my 5 variables, and the one I don't care about is the distance. So I go look at my equations, and I say which of these is the right one to choose. And it's the first one. That's the equation that uses the variables that I need and doesn't have distance in it. So let's take these variables and put them into the equation. So I get VF is 20 plus negative 3 times 5. So VF is going to be 20 minus 15, or 5 meters per second. Great. Let's do one more example. Let's imagine again the case where somebody is holding a ball and throws it downwards. They throw it down in 8 meters per second. How far will the ball travel in 3 seconds? So for this ball has initial velocity, what is the distance that it will go? So let's write down the variables that we know. The initial velocity is 8. What about V final? This is the variable that I don't know and I don't care about. Acceleration is going to be g, which is 10 meters per second squared. D is what I'm looking for, and time is 3.0 seconds. Great. So the variable that I don't care about is velocity final. If I look at my equations, there's one of them that doesn't have v final, which is the second one. D equals VIT plus 1/2 AT squared. So that variable is going to fit this equation properly. Let's take the numbers that we have and plug them into the equation. I get D is 8 times 3 plus 1/2 times 10 times 3 squared. I get 24 plus 45. So the total distance is 69 meters. So there you go. Here are the 5 variables that we are going to be considering for the whole kinematics chapter. And you may get to a place after you've done a bunch of kinematics equations where you don't need this method where you write them all down. However, especially at the very beginning, this is the best way to do it, and it's clear-headed. One thing that might happen is you may kind of get on top of this and then go on to other things. When you come back to kinematics, you're not as clear. So probably you're going to want to use this 5 variable method for the rest of the time you use kinematics in AP Physics 1. So the key thing is we need to identify what the right equation is for every kinematics question, and listing out what they've given to us and the thing we don't care about in particular, for me, is the most helpful way to identify the right equation. Do you have any question about these equations? Write your questions in the comments below and I'll read them and answer them.